anything about that? Anybody remember interval notation?
Doesn't the parentheses sign mean open and the bracket means closed?
Exactly. So when I look at problem 2D, which is the one I think we're ready for, that's where we're starting anyway. When I look at this and it says describe and graph, we're talking about a set of numbers between -2 and 6, right? Put our two numbers on the number line. And as Hunter said, the bracket means you close in the dot. That's a closed interval notation. The parentheses means you leave it open. And then we color everything in between. Easy enough, right? So we're talking about all the numbers between -2 and 6, including -2. Now what about E? Don't be frightened by the notation. There's only one number in there, right? So I'm gonna put my 4 on there. Will that 4 have an open or closed?
Closed.
That's gonna be closed. Now what do I do? Shade forever to the left. That's exactly right. So we're talking about this interval right here. All the numbers less than or equal to 4. So if I were going to write it out, it would be x is less than or equal to 4.
How do you know shade to the left though?
Negative infinity. Which end of the number line is negative infinity? Yep. Okay, now we're going to write as an inequality. Now, certainly you can graph this if you want. Both dots open, shaded between, but you're to write it as an inequality. So what would that look like if I wrote it like this, as an inequality? Where is x going to be? Jacob? In the middle. So, exactly. X, the numbers we're talking about, are right in the middle of 4 and 6. So we put a 4 here and a 6 here. Put your x in the middle. And these symbols right here, as Jacob said, are always less thans. They're never going to be greater than. They're always going to be less than. Because you're always going to write the little number first. So you're going to put 4 and 6 right in order. Put x in between, less than, perfect. What about the next one? What's that look like? Well, we kind of just did one like that over here. Graphically, what would this look like on the number line? So it would be closed out at 6, right?
Shaded to the right.
Shaded to the right. So we're not talking about numbers less than 6, we're talking about numbers greater than 6. So x is greater than or equal to 6. Would you agree with me there? Okay. All right, so C, now this is just a picture, and you are writing it as an inequality. So it's a lot like this one. So where is the x going to go in the inequality? The x is going to go in the middle. So we're going to put an x, we're going to have a -1 and a 5. And then what did I tell you? What are these signs always? Less than. But that one's going to have an equal to on it because the dot is closed. If I ask you to write that as an interval, this is an interval. If I ask you to write it in interval notation, how would you do that? You got your -1 and your 5. Parentheses around the -1 and a bracket around the 5. So all 3 of these say the exact same thing. It's just how they're written is different. Liam?
So the signs, so they're always less than?
Always less than, yeah. Because when you write one of these compound inequalities, you always have to have the numbers in the order they are in the number line. So you're always going to put the -1 here and the 5 here, always. Okay, so then number 4, now we are writing in interval notation. So 4 is less than x is less than 9. What does that look like in interval notation? Yeah. 4, 9, always always your two numbers with comma between them and then either parentheses or brackets. What about B?
Brackets, -3, parentheses.
Bracket, -3, 6, parentheses.
Yes,
Yes.
yes.
And what about C?
Brackets, 2, parentheses, infinities.
Okay, since that is one that doesn't have a stopping point, we're gonna need an infinity symbol, right? And since the number, or the shading is heading toward positive infinity, it's gonna be 2 comma positive infinity. Remember, I think we talked about yesterday, infinities are always open. Always. Anytime you put an infinity in a problem, it's going to be open. Okay, switching gears a little bit. What is the additive inverse? Anybody have any idea what we're even talking about when we say additive inverse? Nah. Yeah, you do. It's called the opposite. The additive inverse is the same as the opposite. So if I ask you, what is the opposite, not equals, that's a bad choice. If I said, what is the opposite of -3 plus pi, take a wild guess. What's the opposite? What's the opposite of -3? 3. If you said 3 minus pi, you are exactly right. That is the opposite. What is the opposite of 5? -5. What is the opposite of -2? +2. What is the opposite? Opposite. There it is. So what's the opposite of 16? Okay, so simple. So simple. Speaking of simple, use the distributive property. You've been doing this since about 7th grade. What you may not remember or know is that the distributive property works both ways. Here's what I mean. This looks like a distributive property problem that you're very familiar with. If we're going to do the distributive property here, we're going to take this times both of these, right? All right, so what do we end up with? 12x to the second. 6xy. Perfect. Perfect. Now we look at B. And kids will say, well, Miss Ford, what do you mean I'm supposed to distribute? There's no parentheses. That's because the distributive property works both ways. You either take the parentheses out or you put them in. So factoring is a form of distributive property. So if I said to you, let's factor this, what could come out? An x. And then what happens? There come the parentheses. See? Here are the parentheses now. And what goes inside the parentheses? 5x minus 8y. That's the distributive property. Alright, let's try C on your own there, see what you come up with. You're factoring it now. It's all, there's no parentheses here. You're gonna factor it. Take a minute, see what you can do, and then tell me what you got. All right, who's got an answer you're willing to share? Jacob?
A squared z, parentheses, a plus z to the 4th.
What do the rest of us think? We good with that? Perfect, beautifully done. All right, do D, E, and F. Do D, E, and F. going to share an answer to D?
Then x to the third minus 6x squared y.
Minus 6x squared y. What do you think, kids? She right? Very nicely done. All right, how about E? Anybody want to tackle that? Amina? Nice and loud.
8 20 minus 40.
Okay. This is one of those cases where we're going to get partial credit. But what about 20 and 4? Oh, you can take out more, can't you? So you chose to take out an 8, which isn't wrong, it just isn't enough. Because we can actually take out 4 more. So the best answer would be 32, 5A minus B. That is the best answer. That one is completely factored. Good work. Okay, and we're at this last one here. A little bit tricky. People always mess up this one.
Negative 6x plus 21y.
There you go. And when we're standing up here talking about it, everybody's like, oh yeah, of course that becomes a positive 21y. But when you're in the middle of a problem, sometimes we forget that we have to distribute the negative also. So we have a negative 6x and a positive 21y. Perfect. Anybody have any questions about that? No, that's easy, Miss Ford. Yes, good, it's easy. Now let's do some exponent simplification. All right, so your job, directions say simplify. Okay, so what do you think of when you look at that guy right there? Do you see some canceling? You have x's on the top and x's on the bottom. Whenever you have x's on the top and x's on the bottom, something you're going to cancel. Now, who has more x's, the top or the bottom? The top. How many more does he have? So you got an x on the top, an x to the first on the top. Who has more y's? How many more? So you got one y left on the bottom, and there's your answer. Nothing difficult about it. I'm not memorizing any rules. I'm just using my common sense. I have one extra x on the top and one extra y on the bottom. The next one is a little bit more complicated. How in the world do we raise things to negative powers? You flip it. Does everybody remember that? Very good. Does everybody remember that when you put a negative exponent on a fraction, it flips the fraction over? Now, it still stays to the second power, but now it's a positive 2. We flipped it because of the negative exponent. Now, how do I proceed at this point? Jacob?
Distribute the 2 to
Yes,
both.
you're exactly right. Now, that's really not the right word, and some experts going to be watching this video and saying, but that's basically what we're doing, is we're applying that second power to everything. So it's x squared, y squared, and then please don't forget what goes on the bottom. 9. Everything goes to the second power, including the 3. Oh my. C looks like a real mess. Anybody have any thoughts about how we might start this problem? There's a lot going on. So how might we start? Vince, was your hand up over there?
Yeah, apply the 2 to 4x squared.
Exactly. And when we do that, when we apply that 2 to everything in here, that's the 4 also. So that's gonna become 16 x to the 4th,
Yes.
and then I still have my y to the 5th and my 4x to the 2nd. Now we can start canceling. We've taken care of all the parentheses, so we can start canceling. Jacob?
When we apply the square, do we multiply that?
Yep. Yep, the exponents get multiplied. Because if you think about it for a minute, Jacob, and this is what I really want you all, in the perfect world, this is what you would all do. You would say x squared squared means x squared times x squared, right? And that's x times x, and that's x times x. So what have I got? X to the 4th. I know we have rules. You've memorized the rules for years. If you ever get confused, you can just write it out and you can see exactly what's going on then. Okay, so here we go, canceling, here we go. 4 goes into 16 4 times. So those of you that like to write things down, you can write it like that. That's what's happening. Now, who has more x's, the top or the bottom? How many more does he have? So I got x to the 2nd on the top. That's the only y I have. So I guess I don't need this line. Here's my answer, right? One step at a time. They aren't bad. Oh my. Look at this next one. Now just wait a minute. Don't get ahead of me. I don't know what it is. You've already got it worked out. That's awesome. Tell us what you did. Well, how would you even start this?
I just started canceling.
Just started canceling. I'm not saying that's right or wrong, because I don't know what you did. I have a little bit of a problem with these negative exponents. So I'm really uncomfortable trying to cancel anything with negatives. I like to start by making everything positive. Okay? Now, before, the negative was on the whole fraction, so we just flipped the whole fraction. That is not the case here, right? The negative is only on the x here. So what do? How do I handle that? Move it to the bottom. When you have a negative on just a piece of the fraction, you just move that number. So this x is coming to the bottom. All right? So there he is. I'm gonna take care of him. I'm putting him down there. Now what about this y? He's going to the bottom. What about that z? He's staying up there on the top. All right, what about this x to the 4th? Staying on the bottom. What about this y to the 5th? Going to the top, and the z to the 6th. So that's how I like to start. Do you have to start my way? No. You can do whatever you want, but let's end up with the same answer. All right, let's start combining things. I have an x here and an x here. Now they are not on top of each other. They're right next to each other. They're both on the bottom. So what's that going to give me? A total of x to the 6th down there. Now my y's, I do have some on the top and some on the bottom. Who has more? Top. So 2 more, y squared. And what about the z's? Bottom will have z to the 5th. Perfect. Very scary looking problem, but one step at a time, not too bad, right? Oh, E is an easy one, I think. What's the answer to E? Can anybody tell me? X to the 6th over 27. Why is it over 27?
3 to the 3rd.
3 to the 3rd, and 3 to the 3rd means 3 times 3 times 3. So 27 on the bottom, good. And F has another negative in it, but the negative is on the whole fraction flip it when it's on the whole fraction. And our answer will be
X to the second, 2 to the fourth.
x to the second over 4. Very, very nicely done. All right. A little bit more, and then we're going to talk about something we're going to do on Monday. All right, so we're going to write in scientific notation. Everybody in here's had chemistry, right? So you have, no? Some of us don't take chemistry? But we write in some science class, we do scientific notation, don't we? We've all done scientific notation. Oh, Lord, yes, we've all done scientific notation. It's real simple. All we do is move the decimal point around, right? So if we have to write 314683 in scientific notation, we have to move the decimal point all the way to here, right? Because the rule is that we have to have exactly one number to the left of the decimal point. Our number has to be between 1 and 10. So 3.14683 times 10 to the, now how do I figure out what exponent I put on there? Count how many decimal points I moved. So I went 1, 2, 3, 4, 5. So I'm going to put a 5 here. Now, sometimes we put a positive 5 and sometimes we put a negative 5. If it's a big number, it's going to be a positive exponent. If it's a little number, like the next one, 0.7136, this is a little number, guys. So I'm going to move that decimal point, 7.136, but now my exponent will be negative. Move it one place, it'll be -1 because that original number was small.
So when you move it to the right, it becomes a negative.
Yep. I prefer not to memorize rules like that because I get them all mixed up. So I just remember if I start with a big number, it's a positive exponent. If I start with a little number, it's a negative exponent. But yes, it's about moving right and left. All right, now, number 9. What in the world? Look at that. What a mess that is. Let's take our calculators out and let's look at just the numbers, not the times 10 parts, but just the numbers. So let's take our calculators out. And let's multiply 3.16 times 1.43. So we're multiplying these two. And then let's divide by 1.23. Did you get 3.67?
Yes.
Okay, so let's just start there, 3.67. Now, let's look at the rest of the problem. We have 5 10s here. Oh no, that's a -8. Where does that go? To the bottom? So I'm going to have times 10 to the 8th down here. Oh no, that's negative, so that one's going to the top. So I'm looking at just the 10s now. I have 5 10s and 10 10s. So on the top, I have a total of 15 10s. But on the bottom, there are 8. So what's going to happen? If I have 15 of them over 8 of them, I'm going to be left with 7 of them?
Wait, did you say like 50 or 15?
15. There's 5 of them and 10 of them. It's 15 of them.
Oh,
15.
So you just multiply.
Okay? Little tricky, but do it one piece at a time, and I think you can manage it. Now, this next one is really tricky. Looks easy, but it is tricky. So let's, one piece at a time. Multiply 3.85 times 4.96 on your calculator, please. Just the numbers. Forget the tens, we do them separately. Just the numbers. What do you get when you multiply these? 19.096. Okay, times 10 to the, well, I got 10 of them here and 13 of them there. 23. Now that seems so easy. Anybody notice anything?
All the decimal points.
Yeah. Are you allowed to have a 19 here? Now, that's what came out. It isn't wrong. That's what we got, but that is not scientific notation. To put that in scientific notation, we're going to have to move it over to here, right? So it's 1.9096 times 10 to the
24.
I heard a 24 and a 22, and it's one of those for sure. Here's what I want you to think about. Just stop and think for a second. Whatever I do here, these are supposed to be the same number, right? I'm just rewriting it in better form. I went from 19 to 1.9. So I made this part of the number smaller. Would you agree? I went from 19 to 1.9. If they're supposed to be the same number, if I made this part smaller, don't I have to make this part bigger? So this is going to be 24. If you make the number part smaller, then the exponent has to get bigger. If you made the number part bigger, then the exponent would get smaller. Wild and wacky stuff for sure. Okay, one more section there. Everybody's favorite. Which property is illustrated? Just look at the whole list. Do you know any of those properties? Can you fill any of those in?
Yes.
Which ones do you know? We have A, B, C, D, E, F, G, H. Okay, so which ones do you know? Let's fill those in first. Okay, I hear up here, he thinks E is associative of multiplication. What do you think? He's exactly right. Because what happened in problem E, we have 6 times 4 times 3 and 6 times 4 times 3. We left everything in the same order, we just regrouped it. And when you group, think about making a group yourself. It's who you associate with. When you group things, it's an associative thing. Regrouping is associative. Very good. Very good. Anybody know another one? David?
I don't know if it's right, but D isn't it like identity?
D is the additive identity. That's right. So it's the additive identity, or you can say identity for addition. You just got to have addition and identity put together. When you add 0 to something, you get the same thing back again. Very nicely done. Yeah, Hunter?
Isn't C commutative property?
C is definitely commutative. Oh my gosh, you guys are amazing. Oh, why is C commutative? Because we changed the order. Wait a second. This is the commutative of multiplication. Because instead of doing 6 times parentheses, we did parentheses times 6. So we did the multiplication, but we did it in the opposite order. You okay, Dave? Okay. All right. Who's talking to me over here? Somebody said something.
It's F, commutative multiplication, or not commutative, identity.
Yep, F is the identity for multiplication. We call it the multiplicative identity, but it's the identity for multiplication. Because when you times by 1, you get the same thing back again. Good? Lauren?
I'm not sure if it's right, I think
G might be which one?
inverse.
Multiplicative inverse, you are exactly right. It is the multiplicative inverse for G, because what happens when you multiply 3 times a third? Don't they cancel each other out? And when things cancel out, that's the inverse. You guys are an amazing group. This is really good. Yep.
Would A be distributive?
A is definitely distributive. There's only one distributive property, so you don't have to say addition or multiplication or anything. Just say distributive. Beautiful. What do we got? We only have 2 left. Hunter?
I'm not sure if this is right, but for B, could it be commutative property of addition?
It is exactly right. Very good. That is my trick question, and you got it right. That is commutative of addition. Because in problem B, in both sides, don't we have 6 times the parentheses? What changed? One parentheses was x plus y, and the other parentheses was y plus x. Okay, good. Last one, we talked about this today. Read it right to left. That's distributive. Yep, that's distributive. Distributive in the other direction. Very nicely done. Very nicely done. Everybody good? All right, let's set our notes aside for a second. And either on the desk or on another piece of paper. And if you need paper, we've got all these cards here if you just want to do it on here. We're going to take a little practice quiz, because on Monday we're going to have our first quiz. And it's going to be over all the wild and wacky things that we've been talking about. So I'm going to put some practice problems up here.
Can you have me one too? Thank you. I'm going to like
guys, I thought I had 5 more minutes. We're about out of time here, gang. So, let's quickly go through this. If you wanna shoot a picture, would somebody take a picture of this for me? We'll start here on Monday, go over this before we take the quiz. Can somebody take a picture of it for me? I mean, I know it's on video, but I don't wanna watch the video. And we'll, yeah, cause I gotta let you go. Unfortunately, so shoot a picture of that. We'll wrap this up first before we take our quiz on Monday. Those of you that have not yet brought me your signed papers, Monday's it, guys. Thank you. Thank
So
you
the
so much.
quiz on Monday is over something.
Quiz on Monday gonna be right here, just like this. We're gonna go over this first, since we didn't have time to do it today, and then we'll, take our quiz. Okay?
It's a day one, right? Or day one?
Well, I haven't done it yet, so I don't have. Some of them are easy to share. Yep, that's perfect. All right, have a good weekend.
Oh, we got a quiz already.
Get your acting-
I mean, it's easy, but